welcome to another tutorial. Today we're going to look at a question from Wassce Novdec 2015, question number 9a, and this falls on the circle theorem. That is, we're solving a question under circle theorems, and it reads that in the diagram, that is this diagram that we see here, ABCD is a cyclic quadrilateral, and of course you see the points A, we see A here, B, C, D. So it is a point that runs around a circle, so we call this quadrilateral. That is the four-sided figure A, B, C, D, a cyclic quadrilateral, because it's in the form of a circle. Like it kind of runs around the circle. Now we are told that the line AB, or the chord AB and DC, are produced to meet at P. So we have AB here and we have DC. These are produced or extended to meet at P. So we can see that they meet at P here. It also goes on that AD and BC are produced to meet at Q. So let us also look at AD. So we have AD here and we have BC also here, and these are also produced or extended to meet at Q here. And it goes on to say that if angle DQC equals 76 degrees, DQC, so that is angle DQC. So we can see it here. If angle DQC equals 76 degrees and angle BPC equals 52 degrees. So where is BPC? That is B, that is P, and that is C. So that is the angle BPC, that is 52 degrees. And angle BCP equals X, so that is B, and that is C and P, so that is angle BCP. If it is also equal to X, then we have to calculate the value of X. So how do we find the value of X? That is what we're gonna do. So one thing we have to ask ourselves is that what have we been given? First, we are told that angle DQC is equal to 76 degrees. That is the first thing that, or the first angle that we are given, and the second angle is angle BPC is also equal to 52 degrees. And of course we are told that BCP, which we are to find, is also equal to BCP is also equal to X. So the question is that how can we bring these angles together so that we find the value of X? Now if we had found, or if we had these three angles in a triangle, then of course we could have summed all the angles to 180 degrees. That is what I'm talking about. If we had, found these three angles in a triangle, then it would have been very easy, because the sum of the interior angles of a triangle is 180 degrees. So we could have found the value of X, but that is not the case. And if you look at these angles, they are found outside a circle. So how can I bring these two angles together, or should I even say three, because we have 76, 52 and X? How can I bring them together so that I can find the value of X? There is a way to do that. Now I have to be able to send these angles into the circle so that I can apply the circle theorems or the circle laws. Now the first thing I can see here is that the angle here, that is angle BCD, and the angle X are supplementary. In other words, angle BCD plus angle BCP is 180 degrees. So that is the first thing that I'm going to write here. So what I'm going to write first is that angle BCD, that is angle BCD plus the angle X, that is angle BCP plus angle BCP is equal to 180 degrees, and it is equal to 180 degrees because they are angles on a straight line. Angles on a straight line. And let me add that angles on a straight line are supplementary. When we say they are supplementary, it means they add up to 180 degrees. Okay, so angle BCD plus angle BCP equals 180 degrees. But what is angle BCP? Angle BCP is equal to X degrees. So angle BCD plus an angle BCP is x, and that is equal to 180 degrees. So angle BCD will be equal to 180 minus x. So the angle here is 180 minus x. That is the value of the angle here. Okay, so one thing is that I've been able to bring the angle x into the circle, because now I can see that I have 180 minus x as the angle BCD. Now the moment I have this here, then I can apply one of the circle theorems. In a cyclic quadrilateral, opposite angles are supplementary, or in other words, the opposite angles in a cyclic quadrilateral add up to 180 degrees. So I'm also going to write again that the angle here, that is angle BAD, angle BAD plus the angle here, that is angle BCD is also equal to 180 degrees, because in a cyclic quadrilateral, the opposite angles are supplementary. So let me add something very small here to explain myself here. I'm saying that opposite angles in a cyclic quadrilateral, they add up to 180, or they are supplementary. Supplementary angles are angles that add up to 180 degrees. So can I find BAD? Of course I can. So let me see angle BAD plus angle BCD, which is 180 minus s. Can you guess the value of angle BAD? Of course, angle BAD will be x, because x plus 180 minus s gives 180 degrees. All right, so that is equal to 180, and angle BAD will be equal to 180 minus 180 plus x, and of course this will cancel, and angle BAD, as I said earlier on, will be equal to x degrees. And this is very simple. So here is x degrees, so we have x, and we have 180 minus x. So our first job, we have been able to bring the angle x into the circle, and with that we can apply circle theorems. Now how can we still find the value of x? We have used x here, we have not even touched on 76, we have not also touched on 52. There is one thing here. If I can find the angle here, then I can consider this triangle, that is triangle ABQ, because the sum of the interior angles of a triangle is 180 degrees. I know x here, I know 76 here. If I can bring another angle here in terms of x, then I can sum all of these to 180, that is x plus the angle here plus 76 degrees. I can also decide to find the angle here, so that I'll sum the four interior angles to 360 degrees. Whichever way I go, I get the same answer. So let me try the first one here. So how can I bring an angle here? Of course, I can bring this angle 52 degrees here. How do I do that? Now, if you look at this triangle BCP, it has one interior angle not known. All right, here is x, here is 52, and of course I don't know the angle here. But if I extend this line, I know that the angle here is equal to the angle here, because the angle here and there are vertically opposite. But what about the angle here and there? That is, I'm talking about angle ABQ and the angle here. What about this and that? Now, the sum of these two angles is equal to the angle here. Let me try to explain this. For a triangle, the sum of two interior angles is equal to one opposite exterior angle. Let me draw a triangle here and try to explain what I'm saying. Now let this be a triangle, and let me label my triangle A, B, C, and let me even put D and E here, and let me put some angles within my triangle. Let the angle at A here be A, angle here be B, and angle here be C. Now what I'm trying to say here is that If I add these two angles, that is A to C, it is equal to the angle here. So that means A plus C is here. That is the sum of these two interior angles. That is sum of two interior angles equals one opposite exterior angle. And that is very, very true. Yes, and we can prove this. Even if you look at this, it's very, very clear. Now, the sum of the interior angles of a triangle is 180 degrees, right? So that means A plus B plus C is 180. A plus B plus C is 180. That is sum of interior angles. Sum of interior angles. If that is true, then look at this one too. Look at the sum of the angles on this line. The sum of angles on a straight line. Is that not also 180? So if I pick B plus A plus C, is this not also 180? So how do you compare this to this one? We have B here, B there, A here, A there, and C here. C here, C there. Then it is also equal to 180. So you can see that it is very, very true. In the same vein, if I add B to C, that should be equal to the angle at this exterior end, so B plus C. So we say that the sum of two interior angles is equal to one opposite exterior angle. And if you really want to know the exterior angle, always, if you identify the two interior angles, try to identify the third interior angle. If you look at this, that is the third interior angle, and this is vertically opposite to the angle here, so here should be A. So what is left is the exterior angle that should be equal to the sum of the two interior angles. So if you look at this here, we have the third angle should be here, and that is vertically opposite to this, so we are left with this angle. So that means that when we sum x and 52, it should be equal to the angle here. So I'm going to put 52 plus x here, so here is going to be 52. Okay, let me use here. Okay, blue is cool. So here is going to be 52 plus x. So we have the angle here, and we know here to be x, we know here to be 52 plus x, and we know this to be 76. So if we consider the triangle ABQ, the sum of the interior angles of a triangle is 180 degrees. So that means that we can sum x to 52 plus x to 76, and we get 180. We can also find the angle here if we want, and of course by now you have been able to guess this. You know that x2 is vertically opposite to this, so when we sum this and that, because if you look at this, the third angle here is vertically opposite to that, so when you sum 76 and x, you should get here to be 76 plus x. So either you pick this, that is you pick x and 76 and 52 plus x, the triangle here, you sum this to 180, or you can pick the sum of the interior angles of the quadrilateral. So let us go. That is what we're gonna do. So we're going to find the value of x here, and what we will say is that considering, we are going to consider the triangle, considering triangle. Let me look at the shape again. So triangle ABQ, considering triangle ABQ, let's look at the angles that we have there. The angle at, we have angle at A, that is BAD, or should I say BAQ? All right, angle BAQ. So angle BAQ, angle BAQ plus, so the angle at B, that is angle ABQ. We are considering triangle ABQ, okay? So angle ABQ. So we have angle ABQ plus the angle up there, that is the angle 76, angle AQB. Or let me see what we were told. Okay, we were told 76 is DQC, that is from here DQC. But considering this triangle, the angle at Q is AQB or BQA. So I'm going to take AQB, angle AQB, and that should give us 180 degrees. So what is BAQ? From the diagram, angle BAQ is x degrees. So BAQ is x here. And what is ABQ? ABQ is 52 plus x. You can see it here. ABQ is 52 plus x. So ABQ 52 plus x. And what is angle AQB? Angle AQB is 76 degrees, and that is equal to 180. So we go on to simplify here. So we have like terms, we group like terms here. We have x plus x here, and we have 2x, and we have 52 plus 76, and that is 128 equals 180. So we have 2x equals 180 minus 128, and from here we have 2x to be equal to, we subtract 128 from 180, and that gives us 52. So to find x, we need to divide both sides by 2 here, and that gives the value of x to be 26 degrees. Yeah, so the value of x is 26 degrees. In the same vein, you could have summed the angles in a cyclic quadrilateral, but that will be a very long way to go, but that is not bad anyway. We could have summed the whole of this to 360 degrees. That is x here plus 52 plus x plus the angle here, that is 180 minus x, plus the angle there, that is 76 plus x, to 360 degrees. We sum to 360 because the sum of the interior angles of a quadrilateral is 360 degrees. So negative x will cancel positive x, and x plus x, we have 2x. Then we also sum 52 to 180, and when we sum 52 to 180, we also add 76, and we get 308 here. So we're gonna get plus 308, which is equal to 360 degrees. And if we want to find x, then it means x must be made a subject, and when we do that, we subtract 308 from 360, and that is going to be, when we subtract 308 from 360, we are going to get the 52 that we had, and when we divide 52 also by 2, of course we get 26, and that is going to be the same answer, but that's a very long way to go. So if you look at the first one that we did, we used the triangle ABQ, and we sum the interior angles of the triangle. So if you look at this, the most important thing is your ability to use geometry laws to bring these angles within the circle so that you can apply the circle theorems. And one of the most important laws is that the sum of the sum of two interior angles of a triangle is equal to one opposite exterior angle.